So last time I was talking about the cost function very generally, but now we can go into more detail as to what the cost function actually is and how it applies to managerial accounting. So I got this passage right here, and it says that cost functions show us the relationship between a cost and its cost driver, and that we can use the function to forecast or estimate costs. So on a very basic level, we understand that when cost driver activity goes up, it normally drives costs up. And if cost driver activity goes down, our costs or our total costs are driven down. So we understand that relationship. But what if we wanted to find out how much total cost changes based on a small increment in cost driver activity? Well, we're going to use the cost function to actually project and estimate that new total cost. And I should also say that cost functions are useful for seeing how much the total cost, how much is variable, and how much is a fixed cost. So last time we were looking at a cost function or a mixed cost, which was maintenance. And I should say that you can have many different cost functions within an organization. You can have one for labor costs or advertising costs or material costs. We're just looking at this one. And last time I wrote it down as y equals 5x plus 20,000. And that equation was derived from our equation of a line, y equals vx plus f. And just to remind you, the y stands for total cost, v stands for the variable cost, or the slope in mathematical terms. X is the variable or the cost driver, and f is the fixed cost or the y-intercept. And the cost driver clearly showed us the relationship between cost driver activity and the cost, because if we wanted to find out how much cost was associated with 200 students, or I should actually say that X stands for students, it's our cost driver, so the more students we have, the more maintenance cost or janitorial cost we have. So at a cost driver level of 200, we can project that our total maintenance costs will be $21,000. And if we had a cost driver level activity of 400, we would just do the exact same thing, sub in the 400, and we would have a total maintenance cost of 22,000. And if we wanted to also graph this to show how the cost function is graphed on a linear basis, let me just draw the axes. So the y-axis is the cost, and the x-axis is the cost driver activity. So our first point would of course be at the cost driver activity level of 0 students. So if x is 0, we can clearly see that this would be nothing, and y would be 20,000, which is also otherwise known as the y-intercept. So that would be our first point at a cost of $20,000. And our second point is at a cost driver level activity of 200, and our total cost would be 21,000. So it would be a small change, and our line would start trending in a positive fashion upwards, and then cost driver activity of 400, it would be 22,000 as you see there. And then we would draw our final point, and we could draw a trend line to show that there is a positive relationship between cost and cost drivers. So as the cost driver or the number of students increases, cost will also increase. So that's how we would use like a cost driver to project costs. But the thing is, I gave you a cost function where the variable cost and the fixed costs were already known. What if we just had total costs? Because normally you're not going to know the variable and the fixed costs, you're just going to know the totals, the total historical costs. So these total costs are for maintenance, and we're going to have our cost driver of students. And let's say the first data point is $29,000 of total cost and 200 students. Well, if we wanted to put this into a cost function, we would put the 29,000 where the y is, and then we would put the 200 where the x should go. And with that, we wouldn't actually be able to project other costs. This isn't a cost function because we can't project other cost driver level activity or cost driver activity levels. So what we actually need is another data point so that we can actually calculate our slope. So with another point, let's say it's $34,000 and we have 400 students, we would actually be able to use these two data points to calculate our slope, or our variable cost, and using that we would actually be able to figure out our fixed cost. So that's what we're going to see in the next tutorial. We're going to actually calculate our slope using the high-low method, and we'll figure out how to actually get our fixed cost, and then finish off by just writing down our cost function like we did originally in the first part of this tutorial. Okay, so I'll see you guys in the next one where we'll talk about the high-low method. If you have any questions regarding accounting or any other material within our videos, you can tweet us at Notepirate. You can like us on Facebook to receive updates or to share any quick anecdotes about how our videos might have helped. And like always, thanks for watching us on YouTube.